Good morning, this is C Rachana, Assistant Professor of Mathematics, Institute of Aeronautical Engineering. Today, I am going to discuss about partial differential equation. In this session, what are the partial differential equations and what is order and degree of the partial differential equation? What is the difference between ordinary differential equation and partial differential equation? All these things we have to discuss in this session. Partial differential equation. So in the last sessions I have discussed only ordinary differential equation. Now here I am going to discuss about partial differential equation. What is the partial differential equation and what is the ordinary differential equation? Ordinary differential equation means we have one dependent variable and one independent variable. So in that we have differential equation is dy by dx. Here we have suppose any function having y equal to f of x is independent variable and y is depends upon this x variable. Here we have only one dependent variable and one independent variable. Now here we have to learn about the partial differential equation and what is the solution, how we can form the partial differential equation. All these things we have to learn. So what are the partial differential equations? An equation involving one dependent variable and more than one independent variables. In the ordinary differential equation, x is only one independent variable. Now in the partial differential equation, we have more than one independent variable. For example, I am taking the function z equal to f of x comma y. Z equal to f of x comma y, I am taking one equation. In that x and y are independent variables. Suppose any equation having z equal to x and y relation give some values to x and y, automatically z will change. So z is depends upon this x and y variable. In ordinary, y only depends upon this independent variable x. If x change, y automatically change. So if we give some values to x, y will automatically change. So y is depends upon this x variable. So here z is depends upon x and y, two independent variables. I am taking one function like this, z equal to x squared plus y squared. Give some values to x and y, automatically z will change. So z is depends upon this x and y. Now how we can write partial differential equation and how what the degree and order in the next slide we have to know. Those are the concept of a differential equation to include equations that involve partial derivatives. So here z equal to f of x comma y is a equation. X and y are independent variable and z is dependent. So we discussed the differential equation. Partial differential equation means we write dou here and ordinary differential equation we wrote that d. So main difference is there we take dy by dx and here we write dou u by dou x, dou square u by dou x square, similarly and all. So here the first example is dou square u by dou t square equal to c square into dou square u by dou x square. Here u is only one dependent variable. Now independent variables are here t and x. So this is the equation involving u equal to some t and x. T and x are independent variables and u is dependent variable. U is depends upon these t and x. So we write the partial differential equation dou u by dou t, dou square u by dou t square form. So these are the examples, and dou square u by dou x square plus dou square u by dou y square equal to 0. This is some standard equation. This equation we call two-dimensional Laplace equation. And similarly, two-dimensional Poisson equation is dou square u by dou x square plus dou square u by dou y square equal to f of x comma y. So we write partial differential equations is like a dou square u by dou t square or dou u by dou t. First order is dou u by dou t. Second order is dou square u by dou t square. Now what are the partial differential equation? An equation involving derivatives, partial derivatives, and which are one dependent variable with respect to more than one independent variables. So here we have some standard notations. What are those? P equal to dou z by dou x and q equal to dou z by dou y. R, S, T are second order derivatives. R is nothing but dou square z by dou x square. S is nothing but dou square z by dou x dou y. And T is nothing but dou square z by dou y square. So P, Q, R, S, T. These are the standard notations throughout this partial differential equation. So P nothing but Q nothing but first order derivatives. And one more thing here we have to remember in this whole partial differential equation topic, Z is a dependent variable and X and Y are independent variable. So wherever we have Z, X and Y, these are the standard notations in this topic. So P, small q, everything is small. Small p is nothing but first order derivative with respect to x. P equal to dou z by dou x. Q equal to dou z by dou y. And R equal to dou square z by dou x square. And S equal to dou square z by dou x dou y. And T equal to dou square z by dou y square. These are the standard notations everyone should understand and remember these standard notations. PQR first order, R, S, T are second order derivatives. And order and degree of the partial differential equation is same as the order and degree of the ordinary differential equation. So what is order and what is degree? In any equation, the highest derivative is nothing but order and highest derivative power is nothing but degree. In this partial differential equation also we have order is nothing but highest derivative. Suppose I am taking dou square z by dou x square plus dou z by dou y equal to 0. This is a partial differential equation. Why which is partial differential equation? Here we have z is dependent variable and x and y are independent variables. So what is the highest derivative here? Square. 2 is the highest derivative. Dou square z by dou x square is the highest derivative. So the order is here 2. So second order partial differential equation. The highest derivative power is nothing but 1. The highest derivative power 1. Nothing but the power is 1. So which is called here degree. So second order and first degree partial differential equation. So dou z by dou x is p, nothing but which is the first order. Dou z by dou y is q, which is second order. Similarly, dou square z by dou x square, dou square z by dou x dou y, dou square z by dou x dou y or dou y dou x, both are same. We can take either first with respect to y or first with respect to x. Both will get same. And one more, dou square z by dou y square is t. And for example, here we have p square plus q square equal to x square plus y square. What is p square and q square? P nothing but dou z by dou x whole square and q nothing but dou z by dou y whole square, which is equal to x square plus y square. So dou z by dou x is only p. P nothing but first order. So the equation is first order and first order partial differential equation, and this first order means degree 2. So which is first order and second degree partial differential equation. So dou z by dou x and dou z by dou y is first order derivatives and those powers are 1, 2. So those powers are here 2. So this is first order second degree partial differential equation. First, we should know how to form a partial differential equation for the given general equation. Suppose I am taking any function or any equation involving x, y, z, a, b and so on, which is an equation. Here, how many arbitrary constants? A and b are two arbitrary constants. So, first take partial with respect to 1. Partial differentiating with respect to 1. 1 is nothing but given equation with respect to x and with respect to y. So eliminating a and b from those equations, we get another equation that is nothing but phi of x comma y comma z p comma q. After eliminating, if we take with respect to x, we get the equation in terms of dou z by dou x. And if we want to eliminate b, then we'll get one more equation, dou z by dou y. Using these equations, we have to eliminate small a and b arbitrary constants. Then we can get which equation? Here we have to take only one time differentiation to eliminate a, and another with respect to y eliminate b. We have to take only one time differentiation. So definitely we'll get first order partial differential equations. If suppose we have a comma b comma c, three arbitrary constants. For eliminating three arbitrary constants, definitely we have to take second order the partial differential equation. So if two arbitrary constants means we'll get first order partial differential equation. If we have suppose a, b, c, d and more than two arbitrary constants, definitely we'll get second order partial differential equation. So if the number of arbitrary constants to be eliminated is more than the number of independent variables, we get partial differential equations of second and higher order. Here we have one problem, how we can form a partial differential equation. So form a partial differential equation by eliminating the constants from which equation? X minus a whole square plus y minus b whole square equal to z square into cot square alpha. Here alpha is a parameter. In the solution also we will get alpha. So there is no problem with alpha. First check that how many arbitrary constants are there. Here a comma b, two arbitrary constants. So we have to eliminate these a and b by taking partial derivative with respect to x and partial derivative with respect to y. So first take differentiation partially with respect to x and similarly with respect to y. So here we should remember one thing. If we take with respect to x, treat y is a constant. If we take partial derivative with respect to y, treat x is constant. So first I am taking partial with respect to x. So I am taking with respect to x. So then y become constant. So x minus a whole square become 2 into x minus a. Similarly, x square definition is 2x. Here also we have x minus a whole square is 2 into x minus a. Here treat y is constant. So constant derivative become 0. And here z is always dependent variable. We have to take z derivative also. So z square become 2z into dou z by dou x. Here we'll get z is a dependent variable. So that's why z square become 2z. And again z is nothing but dou z by dou x. We are not taking differentiation with respect to z. We are taking only differentiation with respect to x. So that's why z square become 2z and into dou z by dou x. So already we have standard notation dou z by dou x equal to p. So dou z by dou x equal to p. Substitute here. And cot square alpha is a constant here. We are not disturbing anything, cot square alpha. So 2zp into cot square alpha is as it is. So now both sides 2 cancelled and x minus a into zp cot square alpha. This is the after differentiate partially with respect to x equation. Go for the next one, that is differentiate partially with respect to y. If we take differentiation partially with respect to y, treat x is constant. If x is constant, x derivative becomes 0. That's why the first term is here 0. This is differentiation partially with respect to y. We have to take with respect to y, treat x is constant. Constant derivative becomes 0. So 2 into y minus b equal to, again we have to take differentiation with respect to z also. Z square become 2z. Again z derivative is dou z by dou y. Dou z by dou y already we know, that is dou z by dou y is q. So into cot square alpha, that is a constant I am writing as it is. So y minus b equal to, here we got zq into cot square alpha. What is our intention? We have to use given equation as well as equation 1 and equation 2. Use these three equations and eliminate arbitrary constants a and b. That is our intention. So I am replacing x minus a and y minus b in the given equation. I am substituting in place of x minus a zp cot square alpha, in place of y minus b zq cot square alpha. So substituting these two values in the given equation, we will eliminate easily a and b. So that's why we'll get zp cot square alpha whole square plus zq cot square alpha whole square, and in the RHS we have z square cot square alpha. This is the given equation. Substitute x minus a and y minus b in the given equation. We will eliminate a and b. So from this we can take common p square plus q square into cot square alpha whole square equal to cot square alpha. Both sides 1 cot square alpha cancel, and next p square plus q square equal to tan square alpha. In this we have only p square and q square, and alpha is a parameter, that is like constant. So no problem with this alpha. So here we eliminated small a and small b. Now this is the partial differential equation. Why which is partial differential equation? So we are not writing like dou z by dou x and dou z by dou y and all. Just simply we write p, q, r, s, t form throughout this topic. So p square is nothing but here dou z by dou x whole square, and q square is nothing but dou z by dou y whole square equal to RHS as it is tan square alpha. So which is a partial differential equation. Which order and which degree partial differential equation is this? Which is first order. P nothing but dou z by dou x only, which is first order, and the first order derivative is nothing but here 2. First order and second degree polynomial, second degree partial differential equation. So very simple. How many arbitrary constants are in the problem? We have to take those many times or those many with respect to x and y times partial derivative, and eliminate a and b are constants a, b, c, whatever the constants, then we have to eliminate using those equations. Go for the next problem. Here we have log of az minus 1 equal to x plus ay plus b. Given equation, again we have a and b, two arbitrary constants. Here also same, take one time differentiation with respect to x and one time partial derivative with respect to y. In this, throughout the topic, we have to take only partial derivative, not ordinary derivative. What is the difference between ordinary and partial? In the partial, if we take with respect to x, treat y is constant. If we take with respect to y, treat x constant. This only everyone should remember. So now in this problem, differentiate partially with respect to x and y. We get, already we know logarithm derivative is 1 by z. So here 1 by az minus 1 equal to, and here also we have to take z differentiation. A is a constant, and here we have to take differentiation with respect to x. So that's why z become dou z by dou x. Already we know dou z by dou x is p. And in the RHS side, x become 1. We are taking x differentiation. So partial with respect to x means treat y constant. X differentiation is 1 and a is a constant, y also constant. Constant derivative become 0. And b is also constant, that one also 0. So here we have only 1 by az minus 1 into ap equal to 1 and ap equal to az minus 1. This is the first equation, partial derivative with respect to x. And go for the second equation. Now differentiate partially with respect to y. So that is nothing but log x is, already we know 1 by az minus 1, a into z. Z with respect to y, nothing but dou z by dou y. Dou z by dou y is q. So a into q equal to what? X is now constant. If we are taking differentiation partially with respect to y. Then x treat constant. Constant derivative become 0. So 0 plus a into y. Y with respect to y means 1. So a. P is the constant. Constant derivative become 0. Now we'll get aq equal to az minus 1. This is the second equation. Now take 2 division 1 will give a by p equal to or q by p equal to a. Whatever, either addition, subtraction, division, whatever, using only these three equations. One is given equation, first equation or second equation. Using these three equations, we have to eliminate a and b arbitrary constants. Now here, in this, if we want to eliminate a or b, better to take division. So that's why I'm taking here 2 divides 1. Then we'll get q by p equal to a or ap equal to q. Now substitute these three in the given equation. Then from given in the first equation, then we'll get both a and b. Now substitute equation 3 in 1. We'll get in the equation 1 ap equal to az minus 1. So from this we have ap equal to q. So that's why here q equal to q by p into z minus 1. So simplify, then you will get p into q plus 1 equal to qz or pq equal to qz minus p. So here we have p, q, z, p. So there is no a and b. So this is the partial differential equation. P and q are there. So that's why which is first order and first degree. P is nothing but p power 1, q power 1. So degree is here 1. So which is first order and first degree partial differential equation. And here we have one more problem. U equal to x square plus a square into y square plus b square. Here also same, we have a and b, two arbitrary constants. We have to eliminate these two arbitrary constants by taking partial derivative with respect to x and partial derivative with respect to y. So differentiate one. Given equation, I am taking equation 1. Differentiate 1 partially with respect to x. Same like previous one. If we take with respect to x, treat y is 0. So if we take with respect to x, u or z. Sometimes they call u in terms of x and y or z in terms of x and y. So for our convenience, I am taking dou z by dou x equal to x square become 2x and into y square plus b square is as it is. No need to take differentiation of this term because y is a constant. Now similarly take with respect to y. If you take y, similarly x is constant. So left hand side is dou z by dou y equal to 2y into x square plus a square. So nothing but q equal to dou z by dou y is nothing but q. So from 2 and 3 eliminate those a and b arbitrary constants. So I am replacing x square plus a square is q by 2y and y square plus b square is p by 2x in the given equation. Then we'll get 4xyu equal to p into q. What is p and q here? Dou z by dou x into dou z by dou y. So here p or q. Order is 1. P nothing but dou z by dou x. First order. And first order power is here we have only 1. So this is also again first order and first degree partial differential equation. Hope you all understood this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.